Hey guys, welcome to lesson 2. We're going to be talking about calorimetry today. All right, let's get started. Calorimetry, or a calorimeter, helps us identify how much heat or energy is absorbed or released by a reaction. Absorbed or released by a reaction. Remember, we are always looking at it from the perspective of the reaction. Okay, so that being said, we're going to recall this is from yesterday's lesson. If a system is absorbing energy, then it is endothermic. Therefore, our enthalpy, which is a new concept, delta H, will be positive. So I know we're seeing this for the first time, so I'm just going to make a note here off to the side. Delta H means enthalpy. Enthalpy is going to relate to potential energy. Whereas heat is going to refer to kinetic energy. Oh, kinetic does not have kinetic energy, which again will be measured through the change of temperature. Okay, let's keep going. Again, from the perspective of the system or the reaction, if the system or reaction is releasing energy, then it is exothermic. And therefore delta H is going to be negative. Now again, like how I introduced the term calorimeter to you yesterday, we're going to work with delta H a lot more closely in the next lesson. So for now, just trust the process here with me. Now let me give you some properties of a calorimeter. First of all, here we have our calorimeter. Like it's an isolated system. You'll kind of see there is that insulating factor that is around the water or the system. We have a thermometer. That is crucial because we are going to be measuring temperature. Okay. The cover is important because we need to keep it as an isolated system. Now inside, we're going to be looking at the water temperature. So usually the reactions are done in solution. So this here will be considered our reaction, whereas then the outside would be considered our environment. So let's take a look at some of the properties that are part of a calorimeter. First one, the calorimeter has to be an isolated system. Now we know in real life this isn't perfect. Even if you put coffee in a thermos, eventually it's going to get cold. But our ways to get as close as possible to an isolated system. The better the isolated system will be, the less experimental errors that we will have. The next one is that the reaction takes place in a solution. And the last one, we're going to be measuring the temperature. Like I said, that the thermometer is so important. We're going to measure the temperature change of water. And this is going to be how we discover how much energy is transferred. So the temperature change of water will indicate the amount of energy transferred. Okay, now why is it important? Why do we need to use the temperature of the water? Well, first of all, we can't see energy. There's no other way to measure energy except for temperature in this setting. We really can't measure enthalpy, that H value that I had given to you either. So it's all done through a transfer of energy to see how much kinetic energy and potential energy, how much it has been exchanged with each other. That brings us to our next learning goal. I understand that in a calorimeter, the change in potential energy, so change in potential energy, which eventually we will relate it to enthalpy, equals the change in kinetic energy. Change in kinetic energy, which we will eventually relate to Q. Here we are, brings it to our next step. Q is the change in kinetic energy, which will be representing heat. Whenever we are looking at Q, we are looking at heat. We are looking at kinetic energy. So all of these three things can be interchanged, but we're looking at the same thing. This is represented by the change in temperature. I'm just going to shorthand the temperature of, again, the water. Now, we have two situations. We can either have water changing temperature, or we have a material that is also placed into the calorimeter, or the material of the calorimeter. So that would also have to be considered. And we're going to go through scenarios of when and when not to use this material. So we'll either be measuring the temperature of the water or the water plus material. Then we have potential energy, which again is represented by delta H. This delta H is called enthalpy. Potential energy is represented by the change in enthalpy. So change in enthalpy. Okay, delta means change, H means enthalpy. And we can only measure the change in enthalpy, the transfer of energy. We cannot measure enthalpy without the change, because the system is changing and it's reacting, and it's a result of how much temperature is gained or lost. All right, so let's take a look at some of the scenarios. Scenario 1. The system is gaining energy. Oh, I always do that. Gaining energy. So we're working with an exothermic reaction. Ooh, exothermic reaction. Therefore, if the system is gaining, the water, which is considered our environment, is going to be losing. That is the world's worst S. Losing. There we go. Energy. So therefore, the starting temperature is going to be greater than the final temperature. So I'm going to introduce some terms here to you. The T final is going to be less than the T initial. I'm basically saying the temperature will decrease. So T initial and T final is going to be less. Now let's take a look at it. I'm going to set you up for how a problem is going to begin, and then we'll do some class examples when you guys come back the next day. We're going to say energy lost is equal to energy gained. So one of them, the system is gaining and the environment is losing. So in this case, water is losing. Okay, so water is getting lost. Water is losing. So I'm going to just say that this is losing. Since we're dealing with temperature, change in temperature, that means that kinetic energy is going to decrease. And then we said that the system is gaining. Okay, it's gaining. So therefore, we're going to have an increase in potential energy. So then what we're going to do to represent this is we're going to say Q, because we represent heat with kinetic energy. I'm getting that from up here. Heat represents the change in water. And then here we're going to say delta H. I'm going to break this down. Okay, so basically we can either say that the water or the water plus material are going to decrease in temperature. And again, we'll go through how to identify when to use the material and when not to use the material. And that is then going to result in the change in enthalpy. Because again, we can only measure the change in enthalpy based on what happens with the temperature change. So that's scenario 1, refers to exothermic. Let's look at scenario 2. Scenario 2, if the reaction or system is losing energy, it is endothermic. Therefore, that means that the water is going to be gaining energy. Therefore, our T final is going to be much greater than our T initial. So our T final is going to be greater than our T initial. Should probably learn how to write T. Okay, so same thing. I'm going to say temp will increase. Will increase of water. And I'm just going to make that very clear, of the water slash material. Okay, so I'm going to say my T initial and my T final will increase. Same thing. We're going to start off with one system is system's either going to lose or gain. So the energy lost is equal to the energy gained. Now in this case, our system is losing. So we're going to put it on the loss side. System refers to potential energy. So therefore, delta H is going to be losing energy this time. Okay, I was sitting here thinking about where I've made a mistake. I've made a mistake here. I've labeled this wrong. Gaining means it would be endothermic. Okay, system is gaining, it's endothermic, and this would be exothermic. There, that makes way more sense now. Okay, so our water is gaining. Therefore, we are going to be gaining kinetic energy. And we are going to use that formula for Q. And again, that is going to be based on if the water increases temperature or the water plus material are going to increase in temperature. And again, we'll go through that in class about how to identify those scenarios. Okay, so just theoretically looking at it, whenever you read a word problem, there are some indicators of when you should include the material into your calculation. First indication is flame. They mentioned that a flame was used. So flame was used. Okay, this refers to a flame calorimeter. If you see the word flame, it means you need to include the material into your calculation. Lastly, if they give you the mass of the material, so if they provide you with the mass of the material, then you also need to use it into your calculation. So mass of material is provided. Then you also need to use it. All right, so go ahead and fill in these notes, and I'll see you guys in class.